All right, good morning. So as promised yesterday, today's video will be looking at advanced advanced uh visualizations with Seaborn, right? So we looked at introduction to Matplotlib yesterday. So we I was able to show us the basic the basic plots that can be done uh, with Matplotlib. So today we're going to take a step further to look at advanced visualization with Seaborn. So this thing known as Seaborn is actually uh, a Python visualization library, right? So it was built on top of Matplotlib. So Matplotlib acts as what the basis uh, for this Seaborn. And that's why most times before you make use of Seaborn, even have to for you to use Seaborn effectively, you need the support of Matplotlib. But what Matplotlib does that makes it unique, or that we can say we prefer it during advanced visualization, is that it provides high level interface, right? So when you're looking for high level interfaces that uh, that are very attractive, right? And then they're also informative. So you think Seaborn when you want something that will be highly attractive, right? So like having a drawing that is attractive, and then that is as well informative. So the information should be statistically backed up. So this particular library, Seaborn, has that potential to give us informative statistical graphs, right? Sorry, this is, yeah, graphics or graphs. And then Seaborn also is particularly useful for visualizing relationships in data set, and as well handling what categorical data efficiency. Remember what we did yesterday when we are trying to digest the fact that we can do numerical plots, we can do also categorical plots when we're looking at bar plots, and then scatter plots for numerical analysis and visualization, while that of bar plots can be used for categorical and as well as distributional plots, right? So very quickly, how do we get started? We import the necessary libraries. So this particular um, video today, we'll be making use of a data set. So because we are going to use a data set, remember, the library that is used for data manipulation is known as what? Pandas. So we will make use of pandas. And also, mind you, before we were able to use this guy, Matplotlib yesterday, effectively, we did what? We imported NumPy, yeah. So today as well, because we said that Seaborn is built on top of what? Matplotlib. That means invariably we're going to do what? We're going to be depending on NumPy as well. And we now import the main guy, Seaborn, as what? SNS. So all these as this they are just alias, right? When I'm calling them, I don't have to call Simon. I can immediately use this guy here. So it's a dummy. You can decide what to use, but it's preferable you go with um, the popular one. So when an external reviewer is going through your code, he or she will understand what you are actually doing. Then matplotlib.pyplot. So this guy is the foundation of what we are building on today, right? So when having done this, you run this guy. Um, I hope this is gonna run. Yeah, it's gonna run. So, but then I want to kill this kernel. Let me see. I want to kill this kernel. Okay. Let's go over it again so we can. All right, great. Yeah, so we can start from beginning. All right, so we've done that. Then we want to load a sample data set, right? So I think during our project, that's when we are going to work with a data set. And then I think you get a data set as well, following up with thoughts or plans rather from the beginning till now, and then try to see how to follow suit. All right, so the data set we're going to use is actually an inbuilt data set in Seaborn. So Seaborn comes with built-in data sets for practice. So that's what we are going to make use of today. So one of the example data sets with different flower species is known as what? Iris. So this iris data has a lot of has what? A lot of species of iris flower inside of it, and then what we can use it for practice to see how we can perform the visualization correctly. So how do we load this data set? Give it a name. Iris equals to what? SNS, that's Seaborn dot load underscore data set. So it means that we have several data set in this particular Seaborn package. So what's the name of the data set you want to load? Iris, right? So Iris is the name of the data set. So when we run this guy, it's as run. So if you look very closely, how to know that your code has run successfully is it will produce a number, a runtime number, right? So this is the first cell that was run. This is the second one. So this is yet to be how do they call it now? It's yet to be compiled and to be run, right? So that's the main thing, how to know which cell you have run. Okay, so we are viewing the data now. Remember how I talked about us viewing the data with with pandas. So the name of the data dot add open and close a bracket, right? So we have here the sepal length. I think we've used this data before. The sepal width, the petal length, and the petal width. Then the species. So when you look at the length, okay, let's look at this first row, 5.0, 5.0, sorry, 5.1 rather, and 3.5 and 1.4, right? And then the width of the petal is what? 0.2. So when we see this, we say this is what? Setosa, right? And having done that, let's see the types of plots we can generate from this guy. The first one is what? A pair plot. So what's a pair plot? A pair plot is useful for doing what? For visualizing relationship between multiple numerical variables. So when you have multiple numerical variables, so let's say for instance, we have the sepal length, the sepal width, the petal length, and the petal width. So all those guys are what? Numerical data. So if you doubt, let's check the information in this data set. So we be sure that these guys are numerical. So if you look very closely, all of them are floats. They are floating parameters. So it means that remember numerical values are usually what they are integers or floating values. So because these guys are floating values, so we can automatically say that they are what? They are numerical variables. It creates a grid of scatter plots for each numerical combination. So what this guy will do, if I'm taking um, um, the pair plot of those four numerical variables, it will do what? It will create the relationship between this first and the second, right? A scatter plot relationship, right? And then this, it can create with this and the second, the third rather, this and the fourth, and then the other way around, the second and the first, the second and the second, the second and the third. So let's see how that is being done. SNS dot pair plots. So this is how to do it. It's as simple as this. SNS dot pair plots. Open a bracket. What is the data name? The data name is what? Iris. Sorry. Iris. Sorry. All right, great. So huge here is telling you the category or the category actually, because this species guy is the category guy. So it tells us that, okay, for this first row, what's the species of flower that we have, the setosa. Then we can also, let's view this guy from the back and see, okay, yeah. So you see this one, Virginica, right? This one now is a different species of that same iris flower. So you can see very, very well that we have different species. So this hue is just like, okay, let's take for instance, when we have the a map of a particular region, right? And then we want to understudy probably, oh, I don't want to use the topography right now. Okay, we want to understudy the how do they call it now? The land use, right? The land use. So if you want to understudy the land use, you can say you might see that, okay, the northern part of that region is being preoccupied by what? Cattle rearing, right? And then the southern parts might be preoccupied with what? Afforestation and all of that. So it tells us the different things that are being done in that particular region. That's for a map of a particular region with respect to what land use. And then that's particular phenomenon that allows you to understand that, okay, the northern guys are dealing with cattle rearing, and then the southern guys are maybe into agriculture. You realize that agriculture per se, when you talk about afforestation and then timber dealing and all of that. So this shows the same thing. So it will, when the plot is being generated, it will now go through the plots. It will rearrange the plot in such a way that you see all the Sato, what's the name again? Setosa, right? In a particular clustered in a particular region. So I I didn't want to use the word clustering because clustering is something different. And then diagonal kind. What kind of diagonal this thing? We need a kernel diagonal uh KDE, right? And then PLT dot title. This PLT, remember, we imported what matplotlib as PLT. So PLT is invariably is invariably from what matplotlib. So we name it perplot of iris data set. Then PLT dot show. So when you run this guy, it takes time. It will take a little bit of time to run. Reason being that it's 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 creating a plot of each of this variable, relationship between each of those variable, and then relationship between those each of the variable against others and others against itself, right? So here is it now. So I have sepal length here as my vertical axis, and also I have sepal length here as my horizontal axis. So let's look at those first plots. This petal length, sorry, sepal length, the down would be sepal what width, right? So look at the species, the hue I was talking about, the species now. Um, how much of Sato was covered? So you look, this is the curve, right? The same thing is applicable to vesicolor, right? And Virginica. And then if you look at this one, sepal length, you come down, you see sepal width, right? Sepal width. So this was sepal length against sepal length. This is sepal length against sepal width. And then this is sepal length against petal length, right? While this is what sepal length against petal width. So it goes on and on. The same thing is applicable here. Sepal width with respect to what sepal length. The same thing here, sepal length width against sepal width. So it goes on and on. And if you notice something very, very closely, you realize that the diagonal, right? The diagonal is giving us a kind of a distribution. So it means that what um there's a mix up here, but I'll sort out that's later. Okay, so if you look very closely, you see you're having how do we call it now? This guy, the diagonals, right? Is showing us like uh a distribution kind of plot, right? So the next is heat map. Heat map. A heat map is useful for visualizing correlations, right? And distributions in metric-like data. So it uses color gradient to represent values. So this guy now, it shows to what extent this particular variable relates with another variable, right? So I think what it uses is the Bayesian Gaussian score. That's the closer the value is to +1, the stronger positively related that value is to that variable is to the next variable. And the same thing is applicable. The farther or the closer the value is to -1, the strongly negatively correlated. So what this implies is that most people, when they see the negative value, they'll be like, there's no relationship. There's a relationship. The little issue there is that when we have a positive value, it's a strong positive. When you have a positive value that is very close to 1, it's a strong positive relationship, right? Then when you have a negative um value that is close to 1, -1 rather, you realize that what is a strong negative value. So let me explain now. The positive one is showing that as variable A is increasing, variable B is as well what increasing. So there's a direct proportionality, there's a direct what relationship. Let me not use proportional, so I don't mix up words. So there's a direct what relationship. As this guy is going up, I'm expecting as A is going up, I'm expecting what B to go up as well. That's for a strong positive correlation. Then for a strong negative correlation, we'll have that as A is going up, we are expecting what B to be coming down. Is still a relationship. So let's try to see if there is any relationship in this guy here. All right. So if you look very closely, you have sepal length, sepal length. What's the relationship? 1. So across the diagonal, we'll have all its coefficient score to be was 1.0. And if you look at this thing here, yeah, I have 1.0 to be the highest and the 0.4 to be the lowest. Why is 0.4 the least here? It's because of the range of the data that I have, right? The range of the data I have, minus 0.4 rather. If you look at the least value here is minus what? 0.37. That's why is displaying that way. So I can boldly say that sepal length and sepal length are strongly correlated. Reason being that I have sepal length and I have sepal length. So it's the same variable. So if I'm going, let me use myself for example. I have Ebenezer and I am Ebenezer and I am Ebenezer, right? So if I'm traveling to Lagos, it means that Ebenezer is actually traveling to Lagos. So the relationship is there, right? I'm just me, 1, right? But look at this other relationship now. Sepal length, sepal width. So sepal length, sepal width, the relationship, the coefficients rather, the correlation coefficient is what? Minus 0.12. So this guy has a weak correlation between the sepal length and the sepal width. If you notice, it's not close to +1 and it's not close to -1. It's just between the range of 0 and minus 0.1, right? So this guy now, we can say it doesn't have a strong relationship with this. The same, okay, let's say our petal sepal length and petal length. There is a strong relationship, 0.87. So it's okay. 0.82, then this is 0.96. Okay. All right. So this guy, the off one here is what? The weak one rather is what? The sepal width. So sepal width is actually very, very weak. So if you look at it, vertically and horizontally, we have your sepal width to be dropping drastically. So how is this useful to us as data scientists? All right, when I have um a data set and I want to predict and I want to perform I want to train a model that can help me predict or yeah, predict a particular variable, right? And then I have that variable. We're not doing a blind prediction right now. We know the values of the variables. So but we want to just train and see if, for instance, we don't have it, how will it perform? All right, so what I will do is that I will include that my known variable, that which is known as targets, right? I'll include it into this plot now. And then, for instance, let's say it's sepal length that is the main thing we are looking for. So you now look at all the relationship that sepal length has with all other variables. So all other variables become what? The independent variables. And then the one I'm trying to predict becomes what? The dependent variable. So it means that that dependent variable will rely on the independent variable for us to get what? A prediction. It's just like your normal regression line equation, your normal regression line equation that say y equals to mx plus c, right? So the value y is, the variable y rather, is depending on what? X and c, right? So as x being your what? Your horizontal values, and c is the intercept of the regression line. So the same thing is applicable here. That's when you have a target variable. Let's say, for instance, the sepal length. So we want to see how the sepal length is being affected by each of this particular um, values. So there's another way of achieving this, but that's when you've trained your model. And then that one is usually known as feature importance. So that one looks at the contribution each of those variables had during your prediction. So we'll do that when we get to machine learning and all of that. All right, that has been explained and well there so long. Let's look at categorical plots. Categorical plots, Seaborn provides multiple ways to do what? To visually to visualize what? Categorical data. So we have box plots, it shows distribution and outliers, right? And then distribution, when we plot it, I'll explain. Similar to box plot, we have violin plots. Then we also have what? Bar plots. The bar plot does what? It displays the mean value with confidence interval. So let's try to run this and see. So this is for box plot. All right, look at it very closely. Box plot, what box plot does is it shows you what? The distribution, right? So we have box plot of sepal length by species. So we want to see the distribution of each of the species with respect to what? Sepal length. So we have Setosa. We will realize that Setosa has Setosa is found around 4.0 down to 5.9 region of the sepal length. Then for vesicular, right? Vesicular, right? It begins from, let's say, around 5.0 to 7.0. Then Virginica. Virginica actually started from 5.0, but then it has majority of its guys from 6.0 down to 8.0. So this guy here becomes what? An outlier for Virginica in sepal length. So another beautiful thing that this guy does for us, boxplot, is that it will tell you whether if there is an outlier. Reason being that this tail end is what? The down part of this box plot is the minimum value that is expected in that particular distribution. Then the upper one is the maximum that is expected for that particular distribution. And then this upper part of this box forms what? Your 75th percentile. The lower part forms what? Your 25th percentile. And then the middle line is what? Your 50th percentile. So your 50th percentile is usually referred to as what? The median of that particular variable. All right, so let's do the violin plot. So let's run this guy. So our violin plot, the same thing is applicable. So now we are looking at petal width by what species. So if you look very closely, it tells you this is how much. So one thing with violin plot, it shows you where the distribution is dense, right? So I have it here. This place that is expanding, it means that I have more values around here. And then the white dot in inside of all of this violin plots are what? The median of that uh, of the plot. Then the upper limit here forms of 50th, sorry, 75th percentile, and the lower your 25th percentile. So let's also look at a bar plot. So this bar plot now, uh, we said that the bar plots will display mean values and confidence level. So its confidence level is about, I think, 0 point something, right? Because of, look at where it comes from here. So if here to here is 0 0.5, this guy should be 0 0.0 something, right? So the same thing is applicable for this ones. So styling plots for professional presentation, you can style your plots depending on what you want. So let's see. Um, the first thing to do is what? A it sets a background you want to use. So here we say white grid and then the text content talk, right? So let's try to see if this comes out well. So you see, we're having a scatter plot, but it's very much informative. So you can see the species has this guy, and this one has this guy. So you have an exercise here that says you print exercises, right? And then create a pair plot for the Pingu data for the Pingu's data set available in Seaborn. Then generate a heat map for flight data set showing monthly passenger, right? And then create a violin plot for the Titanic data set. All of those guys are inherent Seaborn. So do this and let's see how it goes. Ensure you have a great day.